Today we have here another integral. We've got the integral from 0 to pi of x times sine to the fourth x plus cosine squared x dx. Okay, I know exactly two ways to do this anyway. The first way I know is integration by parts. If you differentiate x, this part right here is not that bad to integrate. And I think that's a fine way to do it, maybe even faster. But what I want to do, I just thought it'd be interesting to do it using King's principle. Let me know if you did it with integration by parts and if maybe that way is easier. But let's get started with King's principle on this. So first what I'm going to need for our formulas, we're going to need a value for f of a plus b minus x, where, let's see, b is going to be pi and a is going to be 0. And so with all of this here being f of x, what we're going to need, adding the bounds, is going to be f of pi minus x for the whole integral. So we'll go ahead and rewrite this integral. First, the bounds stay the same, and then everywhere we have an x, we're going to input pi minus x. So first, for the first part, we'll have a pi minus x here, and then this will be pi minus x. And then over here on cosine, we're going to have pi minus x. And then on each of these, here and here, we can use the supplementary angle formula. The supplementary angle formula for sine is just going to return sine x into the fourth, so this is just going to be sine to the fourth x. For this one, the supplementary angle formula for cosine pi minus x is going to be just minus cosine x. But all this is squared, so we're going to end up with cosine squared. Squaring the minus 1, the minus sign just goes away. But then from here, what I can do is let's distribute in this pi minus x and split this up into two integrals on the minus sign. So for the first one, we'll have this pi, but I'll bring the pi out front of the integral. And then we're just going to have on the inside the sine to the fourth x plus cosine squared x. And for the second one, we'll split it on the minus sign here, and we'll just rewrite all this in this form here. And then now we can make the observation, if this original integral, we'll call that I, this here is identical. This piece is going to be I as well. So let's set this whole thing here equal to I. And then what I can do is if I add an I on both sides, add an I here. And so on the left side, this is just going to become 2 copies or 2I. But now at this point, this integral shouldn't be too bad. We're just going to need to reduce the power. Before I do that, let's divide off 2 here on both sides. Divide by 2 here, so we have just pi over 2. And then here, let's just start working on reducing this. So for cosine squared x, the power reduction I have on that is going to be 1/2, 1 plus cosine 2x. Really similar on sine squared. Let's not deal with sine to the fourth yet. For just sine squared, we're going to have 1/2, 1 minus cosine 2x. But to get the sine to the fourth, we need to square this. So we'll square this whole thing here. Then I'll multiply this thing out. First squaring 1/2, we're going to have a 1/4 in front. Distributing all this part, we're going to have 1 minus 2 cosine 2x, and then plus cosine squared 2x. But then on this piece right here, I need to just reduce this again with the same exact formula, doubling the angle again. So this is going to become 1/2, 1 plus cosine 4x. But now let me just distribute everything in and try to clean it up. So then distributing into 1/4, it's going to be 1/4. 1/4 times a 2, we're going to be minus 1/2 cosine 2x. 1/4 to 1/2 here is going to be 1/8. Then distribute the 1/8. Then we're going to have plus 1/8 and then plus 1/8 cosine 4x. And then here we're going to have a plus 1/2 plus 1/2 cosine 2x. If I combine all these constant terms, then what's going to happen is this is going to become 7/8. Half cosine 2x minus half cosine 2x is going to be a 0. That goes away. And now let's just take this value right here, plug it back into the integral, and finish it off. And at this point, I think I'm ready to integrate. Let's do one more thing. I'm going to just factor out a 1/8, bring it out front of the integral just to kind of clean this up a little bit. And now we'll go ahead. So we'll factor this out now as a pi over 16. Integrating, this is going to become 7x. Cosine 4x integral is going to be sine 4x, but I need to bring the 4 out in the denominator as a 1/4, and we just need to evaluate from 0 to pi. Now when you evaluate at 0, everything's 0, sine at 0 is 0, get rid of that. When you look at plugging pi in here, sine of 4 pi, that's going to be 0, so we don't have to worry about this term. We just need to plug in a pi right here. So this becomes 7 pi. Multiplying it all together, for my final solution, we have just 7 pi squared over 16. I actually got this from a formula that was in the JEE main, where if you have an integral where you can use King's principle, you can like eliminate the x, and take an average of the bounds. So that's exactly how we went from here to here. Anyway, that's it for today. Thanks everyone for watching. Have a good day.